Hi everyone, this is my latest project. I've called you WM1. It's 3D printed enclosure with inside, you can see, there is a circuit with USB-C connector. Here inside there is a crystal, 20 millimeters, 20 millimeters, 25 millimeters. This is the size of a cesium iodide doped with sodium crystal, coupled to two micro FC 60035 CPM, 6x6 millimeter size of active part of the CPM per each CPM. This is the circuit with an audio codec which captures the pulses and send to the computer. And on the left you can see 3 op-amps that amplify and shape the pulses coming from the CPM. On the lower part, on the other part of the PCB, you can see the voltage converter that sets the bias, that generates the 40 volt bias for the CPMs. What I'm going to do is taking a thick lead castle, drop inside a small alternate source, this way, insert my device inside, okay. This will shield the crystal from the radiation that is around it, except from the radiation which comes from the source under examination. One moment. Okay, it's connected, and now let's configure Becquerel monitor and take a spectrum. Okay, here we are. You can launch Becquerel monitor, tools, edit device configuration, new, WM1 bis, 1 hour integration time, 1 kilo channel, save. Now press device specific and set up the input line in USB audio codec. Select the sampling rate and everything okay. Start. This is like an oscilloscope that helps us to identify the correct parameters of acquisition. Stop. Sample width 42 beans. Okay, now I see my pulse. Let's set the LLD like 01 and ULD 100. Start. No, too low. 02, too low. 05, okay, it works. 04, okay. Let it acquire some kilo pulses, like 1 kilo. This will generate a matrix that will be used by the software to identify what is a pulse and what is not a pulse. So it's for pulse recognition. Stop. Copy the value at there, 04. Shift result to 95%. Okay, 98, 95 is okay. Then everything okay. Auto setting, yeah. Save, close, and now we are ready. File new and close the ROI. Fit will expand horizontally the spectrum, and now I can press start and spectrum will appear. Time will pass, spectrum will appear. Something that you must be aware of. Look, I have two input microphone array for the registration of my voice and line input. When you press on line input, you can select volume control and set the slider to like 50%. Then regulate it by careful looking the spectrum while acquiring. The effect of the audio gain is to expand the spectrum to the right. This way, you can see I've already chosen the right value. In my case, is 65%. Okay, and we can already see radium peaks here, and bismuth peak, that is the standard spectrum that I expect from an autunate uranium ore. It's completely normal. It's exactly what I've expected to see. Actually, this software is quite efficient. You can look at total counts and valid counts. This will help you to decide if there is too much noise, or maybe you have too many corrupted pulses, etc., etc., etc. And yeah, after all, you can see the count rate. You can see that you can select various other options, like the background. You can smooth the spectrum line. You can self-identify isotopes and things like that. Actually, Becquerel Monitor is a very nice software, but now it will take some time. Let's take a look. Let's take a look at what I want to see from an uranium ore. Norm is normally occurring radioactive materials. Uranium ore is natural, so it's not a synthetic isotope. And yeah, here we can take a look around and choose the right one. Yeah, this is from PRA software. Yeah, Gamma Spectacular. You can see that a typical spectrum have 1, 2, 3, 4, 5 peaks, plus these are the radium fingers, plus bismuth peak at 600 kiloelectron volt. Okay, back to our spectrum. We can count 1, 2, 3, 4, 5 plus bismuth. Okay, so we know that, yeah, this is uranium ore because the spectrum is the same, almost the same. Okay, with smoothing we can better identify peaks by using a moving average algorithm that helps to have a better idea about what's happening there, even with a low count rate of pulses. Okay, but anyway, we have to let the system to acquire for about 1 hour to give as many as possible pulses. So I've already done this. I have saved it. Autunate ore inside lead castle. Open. Oh, it crashed. When things goes like that, yeah, maybe it will crash later. Anyway, look at the effects on the spectrum of the various commands. And now let's try to calibrate with energy calibration, then multipoint calibration, pickup channel, and let's select 3 peaks. Lead, bismuth, and again bismuth. I know these 3 peaks because I have a bit of experience. The first one with 351 kiloelectron volt, 351. The second is 608. Double click. Oh yeah, 608. The third is 1120. Okay, then press execute calibration. Yep, done. You can see that the isotope identifier already put some tags on the peaks. Some are good, some are wrong, But anyway, you have the possibility to modify the way in which the algorithm works. This is the spectra which we have seen previously from PRA, and we can confirm that the peaks are at the right position, the right energy position. We have lead, bismuth, some small peak of radium, because radium is a fractional part of uranium progeny, the K products that build up during years. This is an example of a spectra that is compressed to the left. Anyway, okay, we can see radium fingers and bismuth. We can deactivate the isotope identifier. We can modify and see the delta, the error rate of identification of the various isotopes. And we can modify many parameters on top. I have not too much experience with this kind of settings. Anyway, you can do that. You can experiment with all these settings that Becquerel monitor makes available for us. And yeah, this is linear scale, logarithmic scale, and you can obviously save a lot the stuff, the spectrum. It's a very nice, very beautiful, and very capable software for spectroscopy. I like it a lot, and I can only recommend it. You can find it to download on www.madesp.it. Okay, new file. Oops, what's happening? Seems that it freezed. Yeah, sometimes it freezes. It's not bug proof. So let's close, open, tac, cancel. Okay, new spectrum. Start. I've replaced the ore inside of the lead castle. This is another isotope, single isotope, and it have a very characteristic spectrum. This is cesium 147. Cesium 147 is synthetic because it's man-made from the nuclear reaction, and you can see Compton continuum there, and this is the main peak at 661.8 kiloelectron volt that is used as standard reference for crystal evaluation. So it's 6.5% VHM, and yeah, it will take some time to fix all this statistical madness. We have not enough pulses, so the line is very rough. We need to let it count for a bit, and we will see X-rays caused by cesium. We will see americium 241, and we will see the Compton continuum. So I think it's a good idea to let it run for a while, stop the recording, and yeah, and take it back. Okay, isotope identifier is doing something strange. I have to deactivate it. Perfect. We can already see some peaks, very interesting peaks. We can try to energy calibrate the system, but first let's measure the quality of the crystal, 6%. And these are the peaks that I expect to see on my spectrum. The main peak, americium, cobalt 57, and X-rays from the KX band. Okay, so we can try to use these references to energy calibrate the system. Okay, let's do energy calibration, multi-point pickup channel. Let's select first peak, 661.8. Okay. 66, okay. Pickup channel, second channel. Where is cobalt? I don't know. Anyway, this is 42 kilo electron volt from X-ray. 42. Oh, what's happening? Ah, yeah. 32. Let's try with cobalt maybe, or americium. No, 42. Okay, this peak, I miss a peak. Maybe is that small? I don't know. Let's try with one and let's see what will be with calibration. Select this peak, 121 kilo electron volt. Okay, and execute calibration. No, I've done something wrong. Probably I've picked up the wrong peak with the wrong energy. So reset everything, and yeah, let's do it again. Probably this peak is americium 241 at 59.5 kilo electron volt. So let's use that value 42, then 59, yeah, and cesium main peak is here. Okay, execute calibration. Okay, now I see something interesting, but I don't know where is the other peak. That maybe this is cobalt 57, this one. I can measure the FVHM at that energy. I can measure the FVHM at americium 241 level of energy, the X-ray and cesium. Anyway, the algorithm have some bug and it measures trash, because it cannot be 6.1%, then suddenly 9% is practically an error of interpretation of the algorithm. This is probably one of the faults of this software. Anyway, otherwise it works pretty well, so nothing to complain. Okay, well, let's check. Okay, this is Comto Continuo. Let's check the spectrum. The spectrum is correct. Yeah, it's there. Let's remove everything to see the raw data. 6%, yeah. So is the FVHM estimator that is defective. Oh, okay. This is a long video. Anyway, I hope that it's also interesting. I can only recommend this software. I have a copy of it. You can download from my website. And yeah. What else I could say? I think that yeah, nothing more. Thank you for watching, and see you soon on my channel. Here is the address of my website. In the download section, you can download the free becquerel package. Bye!